have to leave. If you're missing any of the lesson, you can get it, okay?
Okay, thank you.
You're welcome. You just have to remember to post it. All right, let me take attendance first. Make sure everybody is here and ready to do math. And let's get your notes out for E.2. Okay, let's see. Everybody here. Schaefer. Anybody seen Jack Schaefer today? You thought you saw him. And Ava. Those are. Oh, Ava's here. Okay, so we're just waiting for. Jack Schaefer. That's all. That's the only person. There we go. We are ready to do math all together now. Okay, so you will have a bell ringer on Tuesday, and it will cover E1 and E2. You also have my math lab, E1 and E2, due Monday. So make sure that you're doing those, okay? So yesterday we talked about quadratic equations. We talked about the graphs, what they look like, these little U shapes, these little parabolas. We talked about the different components. If we're looking at it in vertex form versus standard form. So the key thing is we can represent quadratic equations in two different forms. Now, if it's in vertex form, yay for us, we can easily identify the vertex, HK. So if we can see it be given in vertex form, or we can easily get it in vertex form, we can identify the vertex, HK. But what happens if we are given it in standard form? If we are given the equation in standard form, well, we're going to utilize these values, these coefficients, the constant, A, B, and C, to be able to represent the vertex by looking at the X value, which will be negative B over 2A. So that is going to give me my H. That's going to give me my X value of my vertex. Once I have taken those values, negative B over 2A, and found that X, I'm going to substitute it back into the equation. And when I substitute it back into the equation, I'm going to get the function evaluated at that input. So remember, function notation, f of x, f of an input. Once I input this x, I just hit the wrong thing. It's one of those days. Once I input this x into the function, I'm going to get f evaluated at that endpoint, the y, the k, okay? So the x coordinate of the vertex is given by negative b over 2a, and that's how you'll have to identify the x value, find the x value if it's given to you in standard form. So let's go ahead and take a look at the different components of the graphs of these parabolas. So if I have a parabola opening up, remember, we can easily recognize that it is opening up if A is positive. If A is negative, then it's going to open down. But no matter how it opens, if it's a quadratic function, it opens up or down. There is an axis of symmetry. Now, again, we talked about how to find that axis of symmetry. If I'm trying to write the axis of symmetry, it is the equation of this line that passes through the vertex. So if given in vertex form, it's x equal h. If it's not given in vertex form and it's in standard form, it's still x over h, but that h is obtained by negative b over 2a. Any questions on that? Okay. Now, let's go ahead and look at an example. What form is this equation being given to you in? It is in standard form. And again, we know that it is a quadratic equation by recognizing that the highest exponent of x is 2. So it's quadratic. If the highest exponent of x was 1, it would be linear. So in this case, I do have a quadratic equation. It is given to me in standard form. So let's go ahead and identify A, B, and C. Let's identify A, which is the coefficient of x. What is A? Anybody want to tell me what A is? 1, thank you. B is -6, and C is 5, okay? So to determine if it opens up or down, I'm looking at my A value. Remember, if A is positive, it opens up. So this is going to open up because A is 1, which is greater than 0. Now, since it's given in standard form, I'm going to have to do a little bit of work to find the vertex. So remember, to find the vertex, I'm going to look at x, which is -b over 2a. So -b, so that's -6 over 2 times a. So that's going to be 6 over 2, which reduces to 3. So my x value of the vertex is 3. Now I have to evaluate the function at x equal 3. So everywhere I see an x, I'm going to substitute in 3. So that's going to give me -18 plus 5, which is what? -4. So the function evaluated at 3 has an output of -4. There is my vertex. That is my HK. Now remember, my axis of symmetry passes through my vertex. My axis of symmetry is going to be written as the equation x equal h. H was 3. So the equation of the axis of symmetry is x equal 3. Now, what is the domain of this and every quadratic function? Beautiful. What is the range? Okay, now the range are your y values. Beautiful, right? Because this opens up, so my vertex is a min. So the lowest y value is -4. Okay, let's try another one. First, you want to identify A, B, and C. What is A? What is B? And what is C? -3. So does this open up or down? It opens down because A is less than 0. A is -1. Now, we need to find the vertex. So to find the x value of the vertex, I'm going to put a little subscript v because I know it's the x value of the vertex. I take -b over 2a, so that's -2 over 2 times -1, which simplifies to what? Is it positive or negative? It's positive. Okay. Once I have x, I substitute it back into my function, and I have to be very careful. Okay, so that's going to be -1 plus 2 minus 3, which is what? Beautiful. There's my vertex. Now we said this opens down, so my vertex is a max. So we got to keep that in mind. What is the axis of symmetry? X equal 1. What is the domain of this and every quadratic function? Okay. And what is the range? Okay, the smallest value that this graph of this function takes on is what? Negative infinity, right? Because it goes down forever and ever. It goes up to and includes -2. So I could technically take this information and start graphing it, right? I have enough to graph it. I even have the equation so I could find other points. So let's say you are given an equation and you're asked to graph it. So I'm going to go through the same process to find some critical values. The most critical value is the vertex right now. So let's find the x value of the vertex. Again, it's -b over 2a. So that's -6 over 2 times 1, which is what? 3. Now I'm going to put that in the kind of the middle of my table because I'm going to want to see the U shape. And since this opens which direction? Since it opens up, I want to make sure that I'm looking at values less than 3 for x and greater than 3 for x. So I'm going to keep going. Now I could either, well, let's go ahead and evaluate the function at x equals 3. So I have 3 squared minus 6 times 3 plus 8. So when my input is 3, my output is what? -1. Let's plot our vertex. 1, 2, 3, -1. There is my vertex. Label your axes. Now, I also know my axis of symmetry is going to pass through that vertex. So I'm going to do a dotted line and say my axis of symmetry, because when we're graphing, we want to label the everything. So x equals 3 is my axis of symmetry. Now, I want to pick values greater and less than. So maybe let's go ahead and choose 2. Shall we choose 2? If I substitute in 2 for x, what am I going to get? When x is 2, y is? Anybody? 0. Will I have an X-intercept? If I go the same direction, oops, I just gave you the wrong answer. If I go the same distance away from the axis of symmetry, in the other direction, remember, because if we fold the parabola, the graph of the parabola on the axis of symmetry, you get a mirror image. So if I go to 4, I already really know what the output is. What's the output? 0 as well. Now, is there anything else I might want to know? Another point on the graph that would not be nice to see and very comforting? The Y-intercept, absolutely. And how do I find the Y-intercept? It's when x equals 0. So if I substitute in 0 for x, what do I get? 8. That's very satisfying. And since I'm there, 1, 2, 3, I can go 1, 2, 3, and I can go up to 8 as well. So we do like to see intercepts. That's a beautiful graph. That's enough. Now, that's graphing in standard form. So let's continue and do an entire problem, start to finish, however you would like to do it. So the first thing I would do is determine, does it open up or does it open down? It opens up. It opens up because a equals 2, which is a number greater than 0. So now I need to find the axis of symmetry. To find the axis of symmetry, I need to look at -b over 2a. So a is 2, b is -4, c is 5. So if I substitute in -b over 2 times a, what is the output? One. So I would write my axis of symmetry as x equal 1. You have to write it as a line. So I could graph that. Axis of symmetry. And I want to see it on the graph. Now, we already have the axis of symmetry, so we have the x value of the vertex. So now I can continue to evaluate the function at that input. And what do I get as the output? 3. So my vertex is the point 1, 3. And we said it opens up. So what is the y-intercept? The y-intercept is when x is 0. It is 5. So the y-intercept written as a point is 0, 5. And if I know that, I know another point. What's another point? Because I know this one, I also know what other point. 2, 5. And I have enough to graph it. And try to make it as curved as possible, rounded at the bottom. It's not an absolute value function, so, you know, let's do our best to make it look rounded and label our axes. What is the domain of this function? In interval form? And what is the range of this function in interval form? What is the min? This is our vertex, which is a min. What is the smallest value? 3. That's a 3 to positive infinity, right? Fair? It's good? Uh-huh.
When you graph it for alpha, is it always going to be like above until
No. No. That's why we're finding these other points, right? We need to know these other points. We have to find these other points. Intercepts are good points to find. I mean, there's always going to be a y-intercept, right? Because their domain is all real numbers, but there may not always be x-intercepts, and we're going to talk about what that means in terms of the solutions. Okay? All right, let's try the next one. We have a function. Does it open up or does it open down? It opens down because a is negative. So I want to find the axis of symmetry. So negative b over 2a is what? Negative 1. So the axis of symmetry is x equal negative 1. And I label it. The vertex, well, I know the x value of the vertex, so now I have to evaluate the y value of the vertex. Ever so carefully, because there's lots of negatives here, so there's lots of room for error. I'm sorry? Is it 0? Anybody get anything different? So this would be negative 1 plus 2 plus 3. So, So the vertex is 1, 4. And since it opens down, right, the vertex is a maximum value. Yes. Oh, you are correct. Negative 1, 4. Oh, I'm having all sorts of issues. It's not letting me erase that. There it goes. Negative 1, 4. No. Yes. There we go.
negative 1 times negative 1 squared? That is equal to negative 1.
Yeah, but there's a negative on the outside. Well, negative 1 squared is 1, and then a negative on the outside. So this becomes 1.
Oh.
And so I have a negative 1. Okay, what is another point of y-intercept? So when x is 0, what is y? 3. So the y-intercept as a point is 0, 3. And if I know that point, what other point do I know? Negative 2, 3. And look at that. There's my parabola. Now, could I find the x-intercepts? I could. That may require some factoring or, we're going to talk about that. But, we would want to find those x-intercepts when we're all said and done. What is the domain of this function? Okay, and what is the range of this function? And including 4. Good. Good. All right. If I ask you to find the minimum or the maximum value, all you're doing is finding the vertex. That's it, right? And then you're telling me the y value of the vertex and where that occurs. So let's go ahead and talk about whether or not this function has a max or a min. Does it open up or down? It opens down, so that vertex is going to be a max. So let's find the x value of the vertex. So that's negative, and then b is 2. A is negative 3. So that's negative 2 over negative 6, which is 1/3. Now I want to find the y value of the vertex. So we're evaluating the function at 1/3. No need to be afraid of those fractions. Okay, so we have 1/9 plus 2/3 minus 4. So I can simplify that first fraction. Negative 3 times 1/9 is what? 1/9 is what? Negative 1/3 plus 2/3 minus 4. So negative 1/3 plus 2/3 is 1/3 minus 4. Before I can add those numbers together, what do I have to have? Common denominator. So what am I multiplying this fraction by? I mean this number. Well, it's fraction over 1. 3 over 3. Okay, so that makes this 1/3 minus 12/3 gives me how many? Negative 11/3. So my maximum is negative 11/3. The max is an at x equal 1/3. So you'd have to write that whole thing out. Okay, let's look at a word problem because there's always a word problem. The height and feet of a punted football can be modeled by this function. So you've been given the function that models the height of a football, where x is the ball's horizontal distance in feet from the point of impact from the little kicker's foot. So I would like to draw a little picture. I have a little person, he's going to kick a little football, and the little football goes like this, right? So that makes sense, right? That looks like a little parabola that opens down, and a is negative in that function, so yay, it makes sense. And x is the ball's horizontal distance. Horizontal distance in feet from the point of impact with the kicker's foot. Based on this model, what is the maximum height of the punt and how far from the point of impact does this occur? So what am I really looking for? I'm looking for the vertex, which is a maximum value, right? That's it. So let's go ahead and take this function and let's find the maximum value. So I'm finding the x value of the vertex, which is negative b over 2a, which is negative 1.18 over 2 times negative 0.01. So getting the calculator out, get calculator out, tell me what that is. How many feet is that? Anybody? 59 feet, okay? So remember, x represents the horizontal distance. So I now know that once I go 59 feet, I'm right where that maximum is going to occur. But now I have to figure out what that maximum value is. So I'm going to substitute back into the function 59 feet for the x, and I'm substituting this into the calculator. And you tell me what the height of the ball is. Bless you. Is that right? So the maximum height is 36.81 feet, and it occurs 59 feet away from impact. Does that make sense? Yes? Could we figure out where it landed? How many feet away does it land? 59 feet further, yeah. So 59 times 2, right? And then I could substitute that back into the function, and I better get 0, right? Neat stuff you can do with math. All right, so let's move on. Let's talk about the solutions to these quadratic equations. So a 0 is a value of the input x that makes the output 0. That's why it's called a 0. The zeros of the function, the solutions that give you an output of 0, are also known as roots, x value of the x-intercept, as well as the solutions of a function. So you may be asked any one of those words and you need to know what it means. So what are there? Are these x values, because if I were to substitute in these x values into the function, I'd get y equals 0. So they are my x values of my x-intercepts. They are my roots, they are my solutions, they are my zeros. So let's think about how that little graph of the parabola could appear on the Cartesian plane. In other words, how many times does it intersect the x-axis, or does it intersect the x-axis, and how many solutions does it therefore have? So I can intersect the x twice. So if there's 2 x-intercepts, I could have 2 solutions. Or it could be a graph where the vertex, whether it opens up or down, falls on the x-axis. So there's 1 x-intercept, so that means I have 1 solution. Or my parabola could never cross the x-axis. There are no x-axis, so there are 0 zeros. And right now we are only talking about real solutions. Okay? Hint, hint, hint. That means there are imaginary solutions. And we'll get to that. So right now, if I'm looking at a quadratic function and I'm looking at the graph of the function, I can tell you how many real zeros there are based on how many times it touches or crosses the x-axis. So how do I find those zeros using a graph? Well, again, we've been given an equation. We can identify A, B, and C. And from using A and recognizing that it is a positive value, we know it opens up because that A is greater than 0. So when I'm graphing, these are the steps I'm going through. Now, C is also the Y value of the Y-intercept. So if I substitute in 0 for X, the C value is the Y value of the Y-intercept. I have some very important pieces I can start graphing. I know that it is going to open up, so I'm going to keep that in the back of my head. I also know that my Y-intercept is 0, 8. So let's find the vertex. The X value of the vertex is negative B over 2A. So negative 6 over 2 times 1, which we said was positive 3. And then the Y value of the vertex is the function evaluated at 3. So what is the Y value? -1. So my vertex is 3, -1. Do I know my axis of symmetry? Beautiful. So I do know another point. So I'm 1, 2, 3. So 1, 2, 3 up to 8. Now, how many solutions is this going to have? I know it's going to have 2 solutions. So how am I going to find those solutions? Well, I could create a table of values. Remember, we like to put our vertex in the middle and then maybe choose values greater than larger. Now, what do you think they're going to be? What do they look like? If we had graphed this a little bit more accurately, what do we think that those X values would be for the X-intercepts? What do you think? It looks like 2 and 4. So why don't we just substitute those in there and see if we actually, what should we get if they are zeros for the Y? 0. Do we get 0 for the outputs? Yes, and then, you know, it's symmetry, so yes. So we have actually found the 2 solutions. So our solutions are X equal 2 and 4. We found them. We have 2 solutions, and there they are, X equal 2 and X equal 4. Now, we could technically factor that, couldn't we? Couldn't we have factored this? What would my 2 factors be? Does anybody know? If I factor that quadratic trinomial, X would be the first ones, right? Because factoring this is a reverse of FOILing. So remember, these 2 numbers have to multiply to give me this, that add to give me that. Positive or negative? They have to add to give me -6. Beautiful. -4 and -2. And then I set that equal to 0 because I want my output to be 0. 0 product property says I could set each of those equal to 0. And look what I get. So we're going to talk about how we can use factoring to solve these. Now, let's talk about how I could use the calculator to answer this question. So what we are going to do is get our calculators out. And I would like you to put in this equation into y equals. So let me switch over to my calculator and share that screen. And let's enter in that equation into the calculator.
Dr. P,
Yes, ma'am.
I have to go.
Okay, okay.
Thank
So
you.
you're just missing the calculator part. So I'll
Okay.
go ahead and do it on the video, but then ask a math friend.
All right, thank you.
You're welcome. Okay, so we're opening up our calculator. And let me share this screen. And make sure that you've cleared everything in your calculator, that you don't have any stray equations, and also that you don't have any plots on. And, you know, because we don't want little scatter plot to appear or anything to cause us any troubles. And I'm going to go ahead and enter in the equation. And can somebody tell me what it is? Because I'm not looking at it anymore. You have your notes. What is the equation? Yeah, we're entering in the one we just did.
Oh.
X squared. So x squared minus 6x plus 8. Now I'm going to graph it. Let's take a look. Ooh, and that's what we got, right? Now, if you look at this, you may say, oh, it looks like 2 and 4, but I'm not 100% sure that it is. So I could go to second graph, which is my table, and I'm saying when x equals 2 and x equals 4, I'm saying those are solutions. So I'm looking at my table for when my output is 0, and look at that. It is true, isn't it? Second graph. So if you just hit graph, it graphs it. But if you go to second graph, it gives you the table. And to verify, you could go to the table and look for when your output is 0. So in your notes, you can go ahead and populate that table for 1, 2, 3, 4, and 5. We know that 2, 0, and 4, 0 are your x-intercepts, and we know that your minimum value is at 3, -1. Agreed? So the zeros are 2 and 4, and they, right? And they occur when the y value is equal to 0. So if you're filling in your notes, go ahead and finish that the next page. Now, is there another way for the calculator to have told us what that information is? Of course, we can go to second trace, which is calculate. And look at that. Look at that. Where do you think we're going to find the solutions, the roots? We go to 0. Select that. And it's saying set a left bound. Now, I think that, I see that it's there. So I need to be somewhere to the left of this root, of this x-intercept. And then you hit enter. And then it's saying, oh, the right bound. So I'm going to go to the right of the root, but you can only have a little neighborhood around one root, or the calculator will just give you one, or it'll get confused, okay? So I set my left bound to the left of the root, and then I came a little bit to the right of the root, and then I hit enter. I don't want you to guess, I want you to tell it to me. So do you see how this is pointing and saying, I'm looking in this window, I'm looking for a root in this window? Then hit enter again, look at that. It found it for you. Now, where is that more useful than looking at a table if you don't have integer values, right? Because your table right now is set up to only count x's by integers. We could adjust that too, but let's not talk about that right now. Now, I want to verify that other one. So I'm going to go second trace, which is calc, go back to 0, And I'm going to now set my left bound, and I'm going to go a little bit to the left of that x-intercept. There's my left bound. And then I want to go to the right of that root. There's my right bound. So it's saying, look in here and find me the 0. There it is. So you can check your work on the calculator, right? You can ask the calculator to help you find those roots, those solutions, those zeros. Or you could look at the table. Now, do you think the calculator can find your max or your min, your vertex? Well, of course. What are we looking for on this graph? It opens up, so we're looking at a min. Again, it's telling you, where am I looking for it? I'm looking for it between this left bound. Go to the right of it, and it doesn't matter where you go to the right of it. And it's saying, look in this neighborhood, and there it was. Isn't that lovely? Okay, so now let's go back to our notes. Let me exit out of here. And let me go back and share my screen over here. And let's see if we can find the zeros of this example. Okay, so again, I like to identify A. A is -1. Ugh. The graph opens down. How do we know? Beautiful. What is B? What is C? 3. Oops. And so the y-intercept is 0, 3. Shall we find the vertex? Let's. Oh, heavens. X value of the vertex, -b over 2a, -b over 2a. So my x value of the vertex is -1. The y value of the vertex is the function evaluated at that x value. Being very careful. What is the y value? 4. So what is the vertex? Let's plot it. -1, 4. So again, you put as many values as you want in there. I'm going to just put this somewhere here. -4. Oops, sorry. -1. And so the point is -1, 4. We already found that. So what's another point I might want to know? The y-intercept, and the y-intercept is when x is 0, right? So when x is 0, we knew that the y-intercept was 3. We had that from 0c, right? But I need to know my x values and my y value. I mean, my x-intercept, sorry. My x-intercepts. So how am I going to find my x-intercepts? Does anybody have a feeling of what it might be? No, you say -3. You want to try -3? I don't know. Let's go ahead and try it. What is my output when my input's -3? And feel free to check it on your calculator, right? 0. So negative 3, 0. 1, 2, 3, negative 3, 0. I have a root. So if I have negative 3, 0 as one of my roots, I should know my other root go the same distance away from your axis of symmetry. At 1. Label your axes. Let's go ahead and just for completeness state my axis of symmetry. Very nice. We have to write it as an equation, x equals negative 1. So what are my solutions? My zeros? X equal what? What are my solutions? Yes. And again, you should be able to put the equation in the calculator, and you should be able to verify your graph. You should be able to identify your vertex, your axis of symmetry, your X values for your solutions. Any questions on this? Any questions on the material that we did yesterday? No questions. Speak now or forever hold your peace. Okay, you have 2 My Math Lab assignments to do, E.1, E.2. You do have a bell ringer on Tuesday, so let's make sure that we have mastered all this material before then. So take the rest of class to work on your My Math Lab. I will be here if you have questions, but talk to your math friends. If you do log off the meeting and you're remote or you're not remote, have a wonderful weekend. You have an extra hour to do math. We fall back. We gain an hour. So that's an extra hour to study. Happy Halloween.